Hello and welcome to SudoKanard. It's been a while since I had a look to ChocChip's blog where he posts, Sudoku that he creates. And so this one is called Picking Apart This One. I'm not sure exactly what he means by that, but it combines two rule sets that I really enjoy. One of them is quad or inclusion Sudoku, which is that whenever you have numbers in such a circle, it means that those digits must appear at least once in the surrounding four cells. Of course, if you give 4 digits, it means that the digits in those 4 cells must be those 4 digits. But in this case, you could have a 4 repeated twice. And then there are x's, which are Roman numerals, which means that the sum of those two digits must be 10, and the v means that the sum of those two digits must be 5. But there is no negative constraint on this very puzzle. So where do we begin? Well, we have lots of pencil marks, and you can notice here that 2, 5, and 9 do not appear in those cells, so they must be here. And those 10 can't be from 1, 6, those digits summing to 10 can't be from 1, 6, and 7. So one of them must be from 3, 4, 8, so it must be here, 3 or 4, together with 6 or 7. We have a 1 somewhere here, together. Actually, we have 1, 6, 7 in here, 3, 4, 8 in here, and we know that 1 is here, 8 is there. Now, we know that 1 and 2 must appear somewhere here, but because of this cell can't contain 1 or 2, so we have a 1 here or there, possibly both. And then, so here, this digit must sum to 5 with this one, so it can only be 4. 5, 6, or 7 would be too big, and that's a 1. So no 1 here, there's a 1 there. And then this is a 5, 6, 7 triple, but 5 can't be here because we will need another 5 here. 6 won't work, it will need a 4 there. So that's a 7 with a 3. There's no 7 in here. Now, because of this does not contain a 4 or 5, so there must be a 4 in here or in there. But this 4 would come with a 1 to make a sum of 5, and there is a 1 here, so that wouldn't work. So that's the 4. So 5 is not here, and 5 is not here because there's a 5 in there, so that's the 5. So you can see that's a neat solving path. We can see exactly how Adam constructed this. Now 4 and 5 are not here. 4 and 5 are here, but they're not here, and because of this circle we must put 4 and 5 in here, and it resolves the 5, 6 pair. Now there's no 4 in this, so the only way to sum to 5 is to have 3 plus 2, so 3 is here because there's a 2 in there. And there, so now this can only be 8 or 9. We need 1, 8, 9 in the column, but this is neither 1 or 9 because they are here. So that's 8, that's 9, and that's 1. Here we need 2, 3, and 8. 8 would come with a 2 here, which would clash. So that's 2 or 3 together with 7 or 8. Fine. And then 1, 2, 3, and 9, so those two digits must be 6 and 7. But 6 here would put a 4 there, so that has to be a 7 with a 3, and 1 is pushed into this cell. And this 3 makes this a 2, this an 8, and we get 6 and 9 at the bottom. No 2 in here, 2 and 9 in there. I'm noticing that there's a 1 in those cells and there's a 1 in those cells. So we have located a total of 2 instances of digit 1 in those 2 columns. So 1 can't appear anywhere else on the columns. So 1, for example, can't be in here. But because of this one, we can't have a 1 here either, so that's the 1. And this 3 is not in here, it has to be here. So that's a 2-9 pair. And this resolves the 8-3 pair in here. Well, where is the next place to look? Here, the missing digits are 4, 5, and 7. That's not 5. Do we know anything about this? I'm not sure. Because of this, there are restrictions on that, but I'm not sure it's interesting. On the contrary, this 10 now uses a small digit and a big digit, but 1, 2, and 3 are here, and this could have been found from the beginning. The only way to do this 6 is with 4. This 10 is with 4 and 6 this way. Here we have 5, 7, 8. So here we must have 1 and 6. And then 4, 6 don't appear in here, so they are here. And this is 5 and 7. So this is now 8. And because of this 4, this 5 can only be 3 plus 2. 3 is not here. This column needs a 1 and a 9, but there's a 9 in here, so that's the 1. That's the 9. And this one is now not here, so the 1 appearing in this square must be here. And the 2 appearing in this square, because of this, is not here, so that's here. And those now must be 2, 7, and 9. That's not 2, that's not 9. Here we need a 5 and an 8, but we know that there's an 8 in here. So 5 here, 8 there. Here we need 1, 2, 3, and 8. 3. Because of this 3, we get a 3 here. 1, 2, 8. This, because of this, we have a 2 in there. And now this 1, 8 is fulfilled. This 2 resolves the 2, 9 pair. This 2 places the 9 in the 2. And what will come here? Well, we know it won't be 1 and 2, it won't be 2 and 8, it won't be 4 and 6 because of this, so it has to be 3 and 7. So 7 here, 3 there. This 3 puts a 4, 8 and 3. This 7 here puts the 6, the 1 and the 7. So that's not 4, that's not 7. 6 and 9 are like this. That's a 2, that's a 9, that's a 7. Nice. This 7 now puts 5 and a 7. And there. Here we need a 2 and an 8. Here we need a 1 and a 5. But this 8 puts the 1 and 8 here, so 1, 5, 4 and 5, and this 4 fixes that. That's a 6. That's a 4, and that's a 9. Right, we're getting there. So this row needs 4, 7, and 6, so that's the 7. That's the 4, and that's the 6. Here I need a 5 and a 4, and that's a 9, that's an 8, and that's it. That's what I would call a coffee break puzzle. And by that I mean if you're working, you're taking a short break. Well, personally, I don't drink coffee, but you see what I mean. You're having a break, you want a nice, fun little puzzle that won't need to find very convoluted logic. You just need this kind of easy puzzle where the solving path is crystal clear and it's fun. It's just a fun puzzle. I don't think there's anything more to say. A fun and easy puzzle. So thanks, Adam, for this for this combination. Well, the two kinds of clues really got together very well. Now, I must say, when I for a long time, the XV constraint always came with the negative rule. And of course, it's much easier not to use the negative rule. But using the negative rule gives way to sometimes more, not necessarily more advanced logic, but you can give fewer clues. Of course, if you're aiming for this kind of coffee break puzzle, well, that's a fair game to use the constraint exactly like this. But it can really be interesting to use negative rules. And I would give the example of some parity party puzzle I did a few months ago, where I combined this with XV with the negative rule. And don't get me wrong, it was quite difficult to create. But it was also very rewarding. Well, that's all I had to add to this. So thanks for watching this video and see you soon on SudoKanard.